Okay, here we go. So we're going to continue with this function business, and today we're going to talk about this thing that we call piecewise function. Okay, so I'm going to give you an example, and then you will know what we're talking about. Okay, so we're going to say example. Okay, piecewise function are important mathematics, very, very important mathematics, because sometimes things behave in a very chaotic way. So sometimes things will behave like in a straight line, and then it will change and behave like a parabola, and somehow from one point will behave like some other stuff. All right. So sometimes things behave like this, like U. Okay. Sometimes things behave like U, and I show you what I mean by that. Okay. Sometimes you are in a very relaxed mode. And so you are, let's say, like this. And then somehow you change behavior. And then you change behavior and you start getting a little bit anxious. Okay, and then you start, calming down again. So sometimes you're going to go like this. Okay, and you're going to go like that. All right? Yeah. And as you see, even human behavior can be modeled using, function. Okay, let's say that this represents you being, in a very, very calm mood, okay, very relaxed mood. And then you get very, very anxious, and then you go, wow, like that, all right? Okay, and then I'm going to move this a little bit that way. And then for some reason you get anxious for something for a little while, and then you start calming down again, all right? Can you see? It's all about maths. It's all about functions, as I said to you before. All right, and we call this a piecewise function because what happened, this function is made up of three different functions, all right? So I mean that in this interval, let's say that this is, say something, -2, all right? In that interval, up to, but not including -2, you behave like this. This open circle, you know what that means? I guess that means that we are not including -2 for this function, but include the -2 to that one, all right? So I mean that this function will take over from -2 to that point, and including that point if you want, or we can do it the other way around. Doesn't matter. All right. Okay. And let's say that from this point, including this point, you're going to behave like this. Okay, you're going to go all the way up to here. Let's say that this is the point. Just say something is not to scale, but let's say that it's equal to 1. Okay, so you're going to go all the way from -2 to 1 exclusive. Can you see that in here we are excluding this one? And then this function will take over. Okay, so we're going to go from here all the way to infinity. Right? Okay, and then we can even describe this. Okay, so we can say this is going to be from -infinity, okay, to -2. Like that. So that is the first section of this function. Okay, and then we're going to put the union symbol. And this time we're going to do bracket square. and we're going to go from -2 to +1, exclusive. Okay, and then we're going to add the other set, and the other set will go, you tell me.
It'll go inclusive 1
Yeah.
to infinity.
Open bracket, like that, all right? Okay, so we call this a piecewise function. And this is important because let's say that you need to evaluate something at -3. So if you need to evaluate something at -3, obviously you're going to be evaluating, or you're going to be using this section of the function, all right? If you need to evaluate this function, because this is a function itself. Okay, so if you need to evaluate this piecewise function for x equal -1.5, obviously you're going to choose this one, right? So if you want to say, what was your move between -2 and +1, then we have to use that function. Otherwise, if I need to evaluate this function for x equal, let's say, 1,000, then obviously you're going to be using this one, all right? Okay, so this function continues and to the right, and this function continues to the left, right? Okay. So that is what we call a piecewise function. Okay, so in this case, the picture is given. We don't know at this point what is the actual function. Okay, so we can find the answer for this. We can find the answer for this easy, but for this one, it's a little bit more complicated. Okay, but we can create a rule or an equation for piecewise function. Okay, so I want you to look at this example. Okay, example 2. We're going to define the function like this. Okay, so we're going to say fx is equal to 3 for x less than let's say -1. We're going to say that the function is equal to x plus 1 for x between, let's say, between 2 and -1. And we're going to say that the function is going to be equal to x squared for x greater than 2. All right. Okay, so you can see in here we have 1, 2, 3 interval. Okay, so we can see clearly. So we can write the interval, and then we can actually draw this picture. And then they're going to ask you to evaluate f -1, f a half, f, all that sort of thing from here. Okay, but I really want to draw the picture for this, and then we are going to evaluate it. Okay, but before we're going to draw the interval. So the first interval starts from -infinity, okay, and go all the way to -1. All right? All the way to -1 exclusive. And then the next interval, min, will go from where to where?
From -1.
Open or close?
Square.
Close, yeah.
Close, yeah.
-1, comma.
To 2. With the square one, close one.
And then we're going to add the other one that start from 2 and go all the way to
Infinity.
infinity. All right. Okay. So that is what is going on. Are you okay up to there? Yes.
What's all the 3 for x plus 1 for squared for?
This, and this?
Yeah.
Okay, so these are how the function will behave in this interval. We're going to draw that. Just give me 1 second. And this is how the function is behaving between -1 and 2. And this is how the function is behaving between 2 and infinity. It's like this, remember? So between this, the function is behaving like this. In this interval, the function is behaving like this. And in this interval, the function is behaving like that, all right? Okay, so let's draw the picture, and then the whole thing will make sense. All right, so we're going to do it in the best possible way. Let me see. Okay, so the first thing that we need to do is to identify the cut point. Okay, so we have -1. So I'm going to put -1 in there. And then from -1 to +2. Okay, so -1 to +2. So let's say somewhere here. All right? Okay, so I mean then here we have how many intervals? So we have one interval, we have the middle interval, and then we have the right interval. Can you see that? Yeah. Okay, they say that the function is going to be equal to +3 up to and not including -1. Okay, so I'm going to say 1, 2, 3, and 4. 1, 2, 3, and 4. Okay? All right, so the function will behave like this all the way from -infinity up to, but not including -1, all right? Okay, what do you have to say?
Oh, go around the
Okay, so here we go. So all the way from infinity up to, but not including -1 is equal to 3. So all right. Okay, do you understand that? Okay, so the function is equal to +3 for any number all the way from -infinity up to, but not including -1. Okay, so that means that if you take, for example, -1.5, if you want to find the image of that, then you're going to go all the way, you're going to meet that one, and the answer is going to be 3. Okay, for any number less than -1, the answer will be always equal to +3. Okay. And then they say for this interval, okay, from -1 to +2, okay, the function will behave like this one, x plus 1. Okay, how are we going to graph that? Well, you evaluate. So you say when x equals -1, okay, when x equals -1, you evaluate that function. Okay, so what is the answer when x equals -1? It's going to be 0. Okay, so that means that we're going to start from here. All right, and then you're going to tell me what happened when x is equal to +1. Yeah. Okay, and then what happened when x is equal to +2? All to 3. Okay, so we're going to go all the way up to 3. Okay, and then we draw the line. Okay, so we're going to draw this line. All right, so far.
And we chose -1 and 2 because that's what it's
Yeah.
for the -1 and 2.
Yeah. Okay. And we're assuming that this function continues. Okay. Later we're gonna explain what continues mean. Okay. And then they say from 2 all the way to +infinity, the function is gonna be x squared, right? And we know that x squared is a parabola, so it's coming this way. Like go like this, like that. So that means that it will appear somewhere here. Okay, so when x equal 2, so we're going to evaluate that one. So it's going to be equal to 4, right? Okay. So when x equal to 2 is going to be equal to 4. And then you need to remember how this parabola looks like. Okay, this parabola looks like this. Okay, so you go all the way like this, like this, like this, like this, and it will continue, all the way to infinity. Okay, so that means that we're gonna do this just to indicate that the function is like that. All right, got that? Yes.
So it starts at 4. Like
Yeah.
that one, yeah.
Yeah.
Okay, so I thought that all of them were connected, but they're not. Like with the first one, with the first example, would those dots actually be connected, or would they be spaced apart?
Yeah, in here we have jump between these two functions, okay? But still we can have an answer for any value that you pick from here. Okay,
Yeah,
so
I just wasn't sure about the spacing, whether you're just doing that so we could see, or
yeah.
if that was
Yeah. Okay, so in here, yeah, you have a jump, but still that is a function. Okay, so this is what we mean by piecewise function. Okay, so I'm gonna put another equation, and you're gonna have a go. Okay, and let's see how you go. Let me check what we have in here. Okay, so this is. By the way, before we do that, I really want you to evaluate this. So we're going to say evaluate. Okay, A. I really want you to find the answer for f at -1. B. I want you to find the answer for f equal to, let's say, positive half. I want you to find the answer for f at -2. D, I want you to find the answer for f 3 plus 2 times f at -5 minus 1. And E, I want you to find the answer for f at quarter square minus f at let's say 0.3, -0.3. -0.3. That's it. Okay, so I want you to find the answer for this operation. All right. So you're gonna give you some time to copy this down, and then we'll do it together. All right?
Why did you put square brackets on A?
Because that indicates that we are squaring the whole thing.
Well, you could just do normal brackets. We always do square brackets for the big ones.
Because there's little ones.
There's little ones on the inside. So we always
Yeah, but
oh, no, I understand. Sorry.
It's okay. It has one of that moments. Okay. These are very, very common question in tests as well. Okay, so you're gonna have something like this, and then they're gonna ask you to evaluate things like that. And also this question in the multiple choice. Okay, so they're gonna say, okay, this is the picture. The answer for this is, and then you're gonna have 4 different options, and then you're gonna have to choose the correct option. All right. Okay, so here we go. So if we are evaluating the function at -1, So which one of these three functions will be using, or I should say, which one of these section of the function will be using, the left, the middle, or the right? Which one? The middle, okay, because the middle include, that one. And we know that f of -1 is, what is it? 0, okay? So f of -1, you can see that is equal to 0. That's it. So that's the answer for that one.
So are we doing this from that graph?
Yeah, so we're doing this from here, okay? And then f at positive half, so we are still in this interval. Can you see that positive half is in this interval?
And we're still referring to those
Yeah,
lines drawn?
we're still using the middle one. Okay, and the middle one say, okay, so this is the recipe, okay? If you are using any number between -1, please use that one. So can you see functions are very, very polite, okay? So they say, please, if you are taking a number from -1 to 2,